Guys, this is the last of the statistics preview, but I think it's probably the most important because we're talking about the normal distribution and the empirical rule. And the empirical rule is also known as the 68, 95, 99.7 rule, and you're going to use it a ton in statistics. So the vocabulary here, we have what a normal distribution is and the empirical rule, and I'm actually going to just go on and move to the next part because they're going to talk about all of these words in a second. So again, this is the normal distribution. So we talked about distributions before, and if you notice, the normal distribution is in fact symmetric. So it kind of folds over on itself and it would be the same on either side. So all normal curves have the same overall shape. They are symmetric, bell-shaped, so they also call these the bell curve, and unimodal. That just means that there's one hump in the middle. There's not like a bunch of different humps everywhere. Okay, you can describe a normal curve by the mean and the standard deviation. So a lot of times you're going to see when they talk about a normal distribution, they're just going to write n, and then they're going to write a number, comma, another number. That's not a point. That's actually going to be the mean and the standard deviation. So I just gave you some more Greek letters here. Due to the symmetry of the normal curve, the mean and the median are about the same. And so here you go, there's the Greek letters. I was like, I don't know where they were. The mean, which we're also going to call mu, that's the weird u, the Greek u, is located at the center of the normal symmetric curve. So this is mu right here. In this case, it would be 0. And then the standard deviation, which is lowercase sigma, controls the spread of the curve. So if you look here, approximately 1 away, this is going to be 1 standard deviation. Okay, this is also 1 standard deviation. So that first chunk is going to be 1 standard deviation away on the left and the right. And then if you go 2, this will be 2 standard deviations, 3 standard deviations, and same thing going backwards. They're just, in this case, negative. Okay, so obviously if your standard deviation is smaller, your bell curve is going to end up being a little bit tighter, and oops, I just totally messed that up. It's going to be tighter in the inside. I totally can't draw is what I've learned. And if the spread is more, then it's going to look like flattening the curve, right? So again, the standard deviation is really what describes how the bell is shaped, if it's going to be tall, if it's going to be flat, and how spread out they are. So let's talk about that empirical rule that I said was super important. So the empirical rule states that 68% of your data, of a normally distributed set of data, is going to be within 1 standard deviation of the mean. Okay, so this right here, this middle line that's really hard to see, that's going to be my mean. Okay, so 68% of your entire data falls within 1 standard deviation of the mean. Okay, after that, you're going to have 2 standard deviations away from the mean is 95% of your data. So 2 standard deviations away is 95%. So most of your data is within 2 standard deviations of the mean. And then 3 standard deviations from the mean, you're going to have 99.7% of your data. So almost all of your data is going to be within 3 standard deviations of the mean. Now, if you notice, this bell curve encompasses 100% of your data. Okay, it's just some of it may be really, really far away from your mean. It could be 4 or 5 standard deviations. It's just highly unlikely. Okay, so what that means is that if you're just looking at half of your data, this right here, this first little point is going to be the mean, whatever the mean was, and you get to add the standard deviation to it. It's trying to be a sigma. Okay, and so then this guy would be your mean minus that standard deviation. Okay, so again, that's 1 standard deviation away from the mean, is 34% of your data, and then 34% of your data. Okay, and if I keep going, this next one right here is going to be your mean plus 2 standard deviations, and over here is your mean minus 2 standard deviations. And then finally, this last one is your mean plus 3 standard deviations, and then your mean minus 3 standard deviations. So with numbers, if you know your mean, you know your standard deviations, you can label all of these things. And again, being in that 99, if you go past that 99.7, that is super rare. Okay, whereas if it's past the 95, it's unusual, but it's not super rare, like if it was above the 99.7. Okay, so let's do some example problems, kind of apply this. Again, I'm not saying that only 99.7% of your data is there. The whole data is represented here. It's just some of your data is more or less unusual to see in this case. Okay, looks like we're going back to the height of dudes. So as of 2010, the mean height of US males is 69 inches, a standard deviation of 28 inches, and is approximately normally distributed. Okay, that is the most important thing they said. It is approximately normally distributed. We couldn't use this bell curve if we didn't know that it was normally distributed. So we're going to label all of the points on this normal distribution. And you're going to get so used to drawing these things. Like I printed it out for you so that way I didn't have to try to draw them because I'm terrible at it. At least on the computer. I'm a little better on paper. But if I know that the mean height is 69 and the standard deviation is 2.8, I can write that with that one notation where I have this is a normal distribution, your mean comes first, and then your standard deviation. Okay, so if you ever see it written like that, that just means that this is a normal distribution, and then they're going to tell you what your mean is and what your standard deviation is. I'm terrible at drawing sigmas, I'm sorry. So the first thing is I'm going to label my mean. That's the middle point here. Your mean is 69. And then in order to label the next points, all you have to do is figure out what those specific things are going to be. Now, I do need to make sure that I've labeled my graph. I just realized I looked down at my nose. I was like, oops. So this right here is going to represent a number of however many. We don't know the number though. We just know the distribution. So we're just going to label our x-axis, which is US male heights in inches. And I probably will never write this again on any of these because we're using the same problem. So to find the next point, all we have to do is figure out what is one standard deviation away. So in order to do that, I'm just going to take whatever my mean is, and I'm going to add whatever my standard deviation is. And I enjoy that I wrote mu instead of 69. So 69 plus 2.8 is 71.8. Okay, and each one of these tick marks represents another standard deviation. So then I can just keep on adding 2.8 and get 74.6 and then 77.4 inches. I also could go back and say this is 69 plus 2 standard deviations, 69 plus 3 standard deviations, whichever makes you feel more comfortable. Same way going backwards. You're going to take the mean, and you're going now to subtract your standard deviation. So in this case, it would be 66.2. Where am I getting these numbers from? I typed in my calculator. And then I'm just going to continue taking away one standard deviation every single time. 60.6. Or again, I could do it multiple times from the 69. Now, the thing here is now I can look at this distribution. We talked about outliers with a set of data from this before. And I could say if I had somebody who had a height of 79 inches, well, he's pretty unusual because he falls outside of 99.7% of my standard, of my mean. Okay, of all of my data. Same if I had a person who was like 60 inches. Okay, so again, this kind of gives me an idea. I have 68% of my data is falling right in between. Oops, I want to use this pen. Right here. So most people are right here. And then 95% of my data falls in between here. So that's pretty unusual if you are below or above that point. And then it's super rare if you're above or below those last points. Okay, so let's do another one. We have the same distribution. Okay, all of you are all going to use the same distribution. So we're going to use the empirical rule to estimate the percent of men that have heights greater than 71.8 inches. So again, we still have that mean height of 69. And then my 71.8 was one standard deviation away. Okay, I didn't scroll back up. So we want heights that are greater than 71.8. So I'm looking for anything that is over here underneath the graph. Okay, so if you go back to that original graph, the one, this pretty color one, these are some numbers that are probably super important to remember, the 34, the 13.5, and the 2.35, because that's taking, for instance, this orange or yellow, whatever it is, it's taking 100 minus 95 and then dividing it into 2. Okay, so that's what it's doing for me there. So in order for me to find this piece, This little part right here in between 1 and 2 standard deviations is 13.5. And then this little piece, the tiny little tail, is 2.35%. And then finally, the like tiny bit of the tail that, remember, whoa, is super unusual. I don't know what just happened. But that tiny bit of the tail that is super unusual is going to encompass 0.15%. Again, super unusual. So all I'm going to do here is add all of these numbers together, and that's going to give me what was that shaded part under the curve. So 13.5 plus 2.35 plus 0.15 is 16%. So approximately 16% of men have heights that are greater than 71.8 inches. Okay, so that's kind of the idea. It says what percent of men have heights between 66.2 and 77.4. So again, we're dealing with the same distribution, okay? And I know that the 66.2 is 1 standard deviation away. And that 77.4, that was that like way far away one. So this is my 3 standard deviations away. So again, I just have to know those numbers that go in between. We want between this, well, I would love if my lines would, yeah, there we go, and this. So there's a couple of ways to do this, but I know that this chunk right here is 34. This chunk right here is another 34. I could have just added 68, but I'm being lazy. Okay, this little chunk right here is 13.5, and then this itty bitty baby chunk right here is 2.35. Okay, again, those numbers are coming from taking the big number and subtracting it from 100 and then dividing by 2 since it's on either side. So if I add up all of those numbers, I get that this percent of men that have the heights between those two particular values is 83.85%. Okay, again, this is just knowing what the empirical rule states. So the next one, what heights do the middle 95% of men fall between? Well, this is super easy because 95% is one of the parts of the empirical rule. Okay, 68, 95, 99.7, just memorize it. So this is 2 standard deviations away from the mean. So I don't even really need to label this if I don't want to. I can take whatever my mean is, and add 2 standard deviations, and I can take whatever my mean is and subtract 2 standard deviations. So if I did that, I would get that that would be between 63.4 inches and 74.6 inches. Again, 95% of your data is going to fall between these two pieces. And so if this was 69, if your mean was 69, 2 standard deviations away would be taking that and subtracting the 2 standard deviations and adding the 2 standard deviations. Okay. The last one is asking about percentile. Oh my goodness. We're scrolling. Oh my gosh. This video is going to take forever because I can't scroll to the bottom question. I don't know what's happening. Okay, I think I fixed it. Okay. So this last one, it says the height of 71.8 inches corresponds to what percentile of men in the US? So percentiles, remember, that are the number that are at or below that particular value. So if I look for 71.8, again, this is the same one that we've been doing. So this was my mean. This is 71.88. There we go. And so what I want to know is how many men fall this direction. Instead of going up, we're going down. And I totally just colored outside of the lines. It's okay. Okay. So the first thing I know is that all the way over here, this is half of my data. Okay. This is 50% of my data on the left side of the mean, or the right side. No, the left side of the mean. Okay. So if I then just take that 50% and add whatever this is, which is 1 standard deviation away, so 34%, that's going to give me my percentile. So they are in the 84th percentile. That means 84% of people are at or below their height. And that is about the empirical rule and the normal distribution.